context. But what we do beyond that is we look at the processes, the science, if you like, behind the claims that are made for the availability of nutrients from these rocks. And that's something we specialise in. So we try to give a robust foundation. And we also look at the carbon capture potential of these rocks, because when you put them on the soil, they're there as a rock powder, and you add them to the soil and they'll naturally weather in the soil. And that weathering process takes CO2 out of the atmosphere. So what we're able to do, working with information that Agrimagined gives us, is to estimate what that CO2 removal is, so that's another benefit that can be quantified by applying them to land.
And then Jennifer said, oh, by the way, I know a very good professor in Newcastle University who could probably help you. So that's how we met. Well, but basically, we calculate for every tonne applied gives us so many kilograms of carbon capture. That's how we work with Newcastle.
We say how much, we get the information about the material that comes from Agrimagined, do our calculations and come back, give them the numbers which they've used in the publicity here.
And from there, when we started to look at it and become even more, then the carbon capture side of it came out, and that's when it was working in Africa. I first started to talk to my brother here, and he says, you what? All right. But then by showing what had happened, it became interesting, and then everything just happened in the last 12 months. Everything has moved to where we are, to what you see today. All right. Vladimir Putin has helped quite a lot in restricting the supply of fertilizers and made everybody rethink. And that's why, and to me, this is the right way forward. We've now, with the professor's help, we've now found rock dust in Nigeria. We've got it in Ghana. We've got it in Angola. We're probably going to have it in Malawi, and maybe with a bit of luck in Thailand. And that's what it's all about. And we've understood what has happened in Brazil.
Yeah, so people are asking about how do you actually measure the carbon benefits, and one of the difficulties with that is that it's very difficult to take a soil sample from a crop like this, as we've got in the field here, and then be able to make a measurement that tells you how much carbon has changed as a consequence of adding the rock dust, because it's too small on the one hand. The other problem is that it's very difficult to do that using a conventional soil sample, because you don't know how deep the carbon has gone in the soil. So some of the carbon will have stayed in the top 10 centimetres, some of it will have worked down, some of it will have drained through to maybe half a metre depth if you've got a free draining soil, which not everyone has. But the point about this rock weathering process, which is taking CO2 out of the atmosphere, is that it is sending that carbon dioxide into the water as bicarbonate, and then the bicarbonate disappears into the water system and ends up in rivers or in groundwater. And we know that process takes place because you can see it in the analysis of any bottled water. So if you buy a bottle of water in the supermarket, you look at the chemical analysis on the side of the bottled water, and you see bicarbonate is there. And that's where it's come from. It's come from recharge of the aquifer through water draining through soils. So that tells you it's happening, but what it doesn't tie back to is the tonnage that you've put on the land of the rock dust. So then we turn it round and we say, what can you verify? Well, you can verify the chemical composition of the rock dust, and then that gives you the information you need to estimate how much carbon dioxide it will take out of the atmosphere if it weathers completely. So that's a starting point. You can then also record how much is left the quarry, because it's monitored for the aggregate levy. So Customs and Excise keeps a very tight control on that. So those are two very, very robust parameters that you can then use. Then you go to the farm, you know how much you've spread. That's not documented and captured in any formal way, but it could be. And that then tells you what your inputs have been. So on the basis of those inputs, you can estimate a CO2 capture per hectare, depending on your application rate. And then to go back in, then we are still at a point where the researchers in the universities have got to come up with a robust way of measuring that carbon in the soil. And they're trying lots of different ways. Some people are using what are called lysimeters, which are columns of soil, and you measure what you put it at the top and you measure what comes out at the bottom and you link the two together. A lot of people are doing that to calibrate models. So lots of different types of computer model you can use to try and calculate this, but you've got to be able to calibrate those models. You've got to be able to measure something to see if the model is right or wrong. And other people are doing even more elaborate things. So we're talking and collaborating with a group in Brazil who are looking at a trench which is big enough for someone to walk into and take samples of the water from the undisturbed soil on either side. So again, they can see what's draining through the soil. And that's helping to capture what's gone through the soil, and then you can measure that and use that to indicate how much carbon is there as the effect that you've had putting the rock dust on. But in a way, you want to turn it all round and say, well, you don't put rock dust on just for carbon capture. The benefits of the weathering of this material are there in the growth of the plant. So you're delivering the nutrition that the plant wants. And okay, you've got calcium, magnesiums, potassium, sodium. They're perhaps the dominant nutrients, but there's also silica. And a lot of plants take silica up. It may have benefits for the plant. The point about that, though, is that the silica can only come from a rock dust like this, from minerals like this, which are inherently unstable. There's no other way it can be supplied to the plant. So in a sense, it's the crop growth that gives you evidence of the effect of the weathering of this stuff, which is the important thing. So taking that, you can see the plant integrates a lot of the analysis and sampling which we struggle to do, but the plant, by virtue of its roots penetrating the soil system, is doing that for you, and really you want to follow what the plant has to tell you.
I think I agree with that, because the guys in Queensland with the sugarcane, which requires a lot of silica, he's found that by applying his rock dust, he's getting far better, more rigid sugarcane instead of it all blowing over, so it's easier to harvest, etc. And the other one that they found out is with the bananas. They've extended the growing period of the banana plant from 3 years to 7 years.
Right.
So that cost of that replanting is suddenly extended and makes the bananas far more profitable to do it. But that's what I see is, looking at where we've applied it, I have a better, stronger, healthier plant.
Yes.
And that is absolutely fundamental.
Yes.
And to me, we've got to keep applying the widest variety of elements for that plant, because we don't know what we've taken out over periods of growth.
Yeah.
And I watched a video yesterday from a New Zealand soil scientist who was actually looking at the impact of peas and beans for the absorption of nitrogen nodules, and she was basically saying that is limited by the amount of molybdenum and cobalt trace element that's in the soil. Well, that is fantastic, because our rock dust has that.
Yeah, that's where it comes from, isn't it?
Yeah. So what she's telling me is we have a natural solution, although it's a very broad brush one, but that's what the plants need in the first place.
They want that breadth. Yeah, they want to be able to get the periodic table out of the soil. Yeah.
And I think and this is where I think we have to be careful with the research. The research is very focused on a particular point, needs to be opened up completely, and that has to be done with trials, field trials like we're doing here, is much better.
Yes.
So when I go to Africa, I say just try it. We're now running trials in Nigeria on a range of vegetables with 3 or 4 different rock soil from that, all made locally. And we're comparing it with the chemical side of it. We're now doing another trial in Kenya for the agricultural show in September, whereby we try lots of different plants which will be transplanted because the time is very short, using RevivaSoil, reusing the microbes separately, and then combined, and see what we come out with.
That's going to be really interesting to see how that
And
works.
he's got a chemical side as well as comparison.
So you really do need trials like this where we are at the moment, and the ones you described in Kenya, because if you don't have that, then you haven't got the opportunity to go in and make the measurements and try different ways of doing those measurements. So the nice thing about this one here is that we can come in with maybe a student project, something like that, look at the soils after the crop and check what the effect's been on the soil chemistry, talk to people here about the yields that they've got and see how the two might correlate and be able to explain and get the whole picture. But if we were to do this ourselves, we would struggle to have everything that you can achieve in a trial of this type in a laboratory, in a small project with just one person doing it.
Yeah, that's what I see. And I think, okay, it's more simple, but it's bigger. It's a real life situation.
Yeah, it is. Yeah.
And I think that's what we need with the farmers.
Yeah.
The farmers will be more convinced by this than they will be what you do in a laboratory. Sorry, but I think that's true.
You need both.
Yeah.
So and we do need to do. We do both. And the important thing is that you've got to make sure that when you do the trials in the lab, you do it in a way that can be interpreted to help with the soil. So one of the problems that there's been with a lot of the trials is that people do these trials, but they never look at what the mineral composition is of the soil itself, mineralogical composition in the sense of what geological minerals are there. And for that reason, in the northern hemisphere, in temperate soils, some of the published trials have not given results which are meaningful, because they're adding a rock dust like this to a soil which has got the same minerals in it already. And that means that you don't actually see any effect of the addition, because you haven't got rid of all the ones that were there to start with. So to overcome that, we do trials where we take a very, very pure quartz sand, which is 100% SiO2, 99.6% SiO2. So there's no nutrition in it whatsoever. And then you add the rock dust to it. So there's only one source of nutrition. And then you can do a crop trial or a plant trial. We often do this with leeks because it's very easy to measure leek growth over a 12-week period, say. And you can see over that period of time the way the plants are drawing the nutrition from these rock dusts. So it's very easy to demonstrate if you've got a pure mineral soil.
So Andrew is putting on a trial. I think it's his father-in-law's farm in Sandyway, in Cheshire.
Yeah.
That's going to be very interesting because
it's very sandy soil.
Yeah,
that will be interesting. But even those sandy soils have some potassium in them. So we look at the glass sands which come from around here in Cheshire, and they're not pure enough for our purposes.
Okay.
So we get a very, very pure sand. The potassium that's in a glass sand is good for glass making, so that's absolutely fine. But it means then if we're after potassium, we want to test potassium, then we really do have to get a different sand for that purpose.
Okay, that's fine.
Yeah, it's fine, yeah.
He's also got, his brother has got a peat farm near Frodsham.
Oh, yeah.
So we put some on a pasture there because he's all pasture. Yeah. So we'll see what happens on that as well.
That'll be interesting.
Yeah, so we're trying to, in different areas and different things to have a look at.
Yeah.
So I think what we've got here is great for a student project.
This will be, yeah.
Because we got here, we got Frodsham, which ain't that far away, and we got Sandyway, which is another 20 miles.
It'll be really good. Yeah.
All the way to Chester. So, yeah. And then there's another farmer here, which is a real crap land apparently. Everybody's tried it. So we put some on there as well to see what happens. See what and yes, we're doing that, and I think that's what we've got, and that's what he's looked at, and I'm really pleased.